Hey guys, it's Mr. Wolf here, and I'm going to be talking about how an electric motor works. All right, for this project, we have three main sections. We have the function, the structure of the materials, and then how the structure leads to the function. I'm going to guide you through this example of a motor, and then you guys are going to try kind of a practice assessment on your own with a generator. So let's first talk about the function of a motor. All right, so doing your research, I was able to find that an electric motor converts electrical energy into mechanical energy. Right? And in terms of like our daily life, well, really any device that we turn on and it moves in some way, whether it's like rotating or doing something else, it's powered by an electric motor. Right. So just some examples of devices, there are tons of them, but one is actually your phone. So like the vibration setting on your phone when it's on silent, that's produced by a really tiny motor in your phone, or a video game controller. Right. A blender would be another example, a fan, a mixer, toy car. These are all examples of electric motors. Right. So now I want to diagram my device as well as talk about some of the structure of the materials that make it up. So first let's start with our device. Well, we have a battery that's going to power a motor, and connected to the battery is we have a wire, and then that wire leads to what we call a brush in a motor. And this is also a wire, but we're going to specifically call this our coil. Right? And that coil is attached to a fan blade. Now we also notice that we have these like two blocks here. These are two magnets, right, that sit pretty close and like around our coil. Right. Now in this example, and for your guys' examples as well, whenever you guys have like any type of magnetic object, I want you guys to draw the domains and the arrows that would be part of this material. And when you're doing your research, you're going to find some possibly like complicated objects. We want to simplify it as much as possible. So when I was doing my research for my motor, my magnet was kind of like the circular one. And in terms of like, I didn't know if which way was north, which way was south. The important thing is that you guys just know that here's a magnet and it's going to generate a magnetic field. You guys get to invent which direction that might be and just kind of make it simple. So for instance, I'm just going to say that this way is north. I'm going to say this way is north, this way is south, and my arrows are going to be going this way. Right. I'm just going to say these are my arrows because it's going to be up to you guys later to explain what these guys are. Okay. Now, a big part of how this device is going to function is also there's going to be a magnetic field that these magnets produce. So I'm going to want to draw my magnetic field lines as well. And in terms of where, like, how you draw them and everything in class, yeah, like we make sure that the whole magnet has lines around it. We care about more getting to the function of our object, and really what matters is the magnetic field around the coil of my object. So that's really what I'm going to draw here. I want to still make it accurate where I have my magnetic field lines going from north to south, but I'm going to care a little bit less in terms of drawing my lines all around here, because honestly it would make it really, really messy. I care about showing my viewer how this object is working. So just that there's a magnetic field right around here, but I'm still being accurate, having my lines go from north to south in this case. All right. And then if you guys look at your rubric for the structure, you need to diagram this out like I did, but you also need to talk about how one of the materials here allows electrons to flow or not flow. So in this case, I have a wire and coil. So I'm going to say the wire and coil are, and then like this type of material right here. I'm not going to say anything just because when you guys do your research on a generator and your other objects, they're going to be fairly similar. So I'm going to leave that up to you guys, but I think you guys could fairly easily think, okay, like what type of material is like a wire in a circuit. So the wire and coil are blank, and not only do you need to say what they are, you need to talk about like the structure of that material. When I say structure, like go down to the atom level. So like go back to Unit 7, Target 1, and like compare insulators versus conductors. What is special about the atoms of, let's say, a conductor versus the atoms of an insulator that allow them to work the way they do? So make sure to include that stuff here. We're getting into a really tiny detail with the structure, and then that's what allows that object to work as like a magnet, or allows electricity to flow or not flow it through it as well. Okay, so then we also have our magnets, and I'm going to say the coil. The coil is not a magnet, but it is surrounded by two magnets. All right. And just like right here, I'm not really going to go into detail. That's going to be up to you guys to figure out, but I'll give you some help in terms of go to like Unit 8, Target 2. This is all what you guys need to be looking into to properly complete the section. And what you want to do is, okay, like here's my magnet. What about like the structure of this material? What about the atoms? What's unique about the atoms of this material? And like the chunks of the material that allow it to behave like a magnet. So now I'm going to go into the function of how this object works. This is my structure to function. So I'll be talking about maybe like the magnetic properties of these objects, the conductive properties of these objects, and also now I'm going to be incorporating the relationship between magnetism and electricity, or electricity and magnetism. So my first step is that the power source and a closed conductive loop allow electric current to flow through the coil. Right? So you can imagine that like once we have this closed loop, electricity is going to flow through my wire right here. Just draw some arrows, just kind of like showing that. Might even label this current. All right. So now my progression is going to be very cause and effect. Okay, now this happened. Because this happens, and then because this happens next. So because I have this electric current flowing through my coil, so I'm going to say electric current produces a magnetic field around the coil, making it an electromagnet. So by running electricity through this coil, it is now a temporary magnet. It's an electromagnet. All right. And in terms of what's going to happen, so you can imagine if this coil all of a sudden has become a magnet, I'm going to kind of show just like the fact that there's this magnetic field kind of being generated around the wires, that it's also in the presence of this magnetic field generated by my two permanent magnets. You could also imagine that maybe one end is going to be south right here and the other end is going to be north. And so if I have a south and south or north and north, they're going to repel each other and they're going to move away. So I'm going to say the electromagnet, the coil, repels from the permanent magnet, causing the coil to rotate. So I'm going to draw maybe just like some rotation right here just to show that that's what's happening with the coil. All right. And if my coil's rotating, so rotating coil, is also hooked up, or I'm going to say attached, to fan blade, which causes the fan blade to also rotate. So kind of taking a step back at this whole thing, we had current running because we have this closed loop and battery. Whenever we have current running through something, well, that makes it a magnet, an electromagnet at the time. Since it's already in the presence of a magnetic field, it's going to repel away from the magnet, causing my coil to spin. Right? My coil is attached to the fan, so the fan also spins, and then this just continues to happen as long as you have current running through it. Now, a couple things to keep in mind in this project. In our investigations and our arguments, we cared about the specifics of constant current creating constant magnetism and changing current creating changing magnetism. For this project, just because the devices get fairly complex, and depending on what type of motor you might have different types of electricity running through it. We care about just the general. So in this case, what we care about is that, okay, we have current running through our coil, it produces magnetism, and because of that, this magnet now repels from that magnet. We don't care about the alternating current in this case, or any type of changing magnetism. That electricity generates magnetism in this case, and maybe for some of your objects later on, that magnetism generates electricity.